Hello everyone. In this video, we will learn how to solve a cubic equation quickly. So consider a general polynomial f of x is equal to a0 plus a1x plus a2x square plus a3x cube and so on up to an xn. This is what a general polynomial looks like, where x is the variable in this equation, particular equation, right? And the coefficients a0, a1, a2, they are the coefficients. They can be any number. Okay. So for right now, we are restricting ourselves only to the condition that we will solve only a cubic equation. So for the cubic equation, we will take this much part of a general polynomial, right? So cubic equation has a power 3 in it, right? So it needs three different roots for that equation. So if we draw the curve of of any particular cubic equation, then what we will see that it will cut the x-axis at three different points, right? These three different points represents the root of that cubic equation. Okay, where this y-axis is our f and this x-axis is our the variable, right? The x is the variable or the root where we can get the roots of this polynomial, right? Cubic polynomial. So for the the idea behind the solving the cubic equation is we will use a much shorter way to solve it rather than any long way. So for that we will learn the Horner synthetic division method. Horner synthetic division method, right? So by far the Horner synthetic division method is one of the quickest way to solve a cubic polynomial. All we have to do, we have to guess one of the root of the cubic equation through inspection, and then rest is easy. So how does this method proceed? How does this method looks like? For that we will consider for example, take a polynomial, cubic polynomial like x cube plus x square minus x minus 1 equal to 0. This is a cubic polynomial, so it means it will have three roots, right? So we have to find these roots, right? So if we draw the curve of this particular equation, it will cut the x-axis at three different points. And what does this Horner synthetic division method does? It shortens the time to find the roots of this of a cubic equation. It is quick, pretty much quick than the conventional ways which we find in textbook. So how does it goes? So for this, we will take the coefficients of these variables, right? These variables, and we will try to find one of the root through inspection, or some people call it hit and trial method, right? Hit and trial. So let's take like x is equal to minus 1 here and see whether it satisfies this equation or not. So what happens if you put x is equal to minus 1 here? Let's see. We get minus 1 cube plus minus 1 square minus of minus 1 minus 1 equal to 0. So it gives minus 1 plus 1 plus 1 minus 1 equal to 0, right? So it means x is equal to minus 1 is one of the root of this particular cubic equation. So let's see what does this Horner synthetic division method does. Take the coefficients, draw two lines like this. First of all, draw two lines like this and write down the coefficients of the variables of x cube, x square, x and the constant. So we have here 1, plus 1, minus 1 and minus 1. So 1, 1, minus 1 and minus 1. So we have found one of the root as x is equal to minus 1. Right, minus 1 over here. Right, now this first, let me change the color. This first coefficient, write down below straight. Okay, now multiply these two numbers. What do you get? Minus 1 into plus 1, that gives minus 1, right? So you have to write minus 1 over here. Add these two. So you get 1 plus minus 1, 0. Now multiply this 0 with minus 1 again. What do you get? 0. Write 0 over here. And add this minus 1 with 0. What do you get? Minus 1. Now multiply this minus 1. Now multiply this minus 1 again with minus 1. So what do you get? Minus 1 into plus 1. Minus 1 into minus 1 is plus 1. Write that plus 1 over here. What do you get? And add these two. What do you get? 0. Right. So this equation which we see here, this is our quadratic equation. X square minus 1 equal to, and what is this? This is our remainder. Okay. So if we solve this, we get x is equal to plus 1 and minus 1. So our three roots are minus 1, minus 1 and plus 1. This is how Horner synthetic division method works. So if you try to verify whether we get the correct root or not, or whether we solve this entire thing or correctly or not, so multiply this equation x square minus 1 with x plus 1, the root which we first found through inspection, x plus 1 times x square minus 1. Let's do this to verify our method. So x plus 1 and x square minus 1. What do we get? X cube minus x plus x square minus 1. If we rearrange it, we get x cube plus x square minus x minus 1. This is the same original equation which we have started with, and we correctly found the roots of this cubic polynomial, which came out to be plus 1, minus 1 and minus 1. So let's take another example and see how does this Horner synthetic division method works. It will clear your idea. Okay, so consider any cubic polynomial. Let's take 2x cube plus x square minus 13x plus 6 is equal to 0. So we have to find one of the root through inspection method or hit and trial method, right? If we see through inspection, one of the root which satisfied this equation is x is equal to, what if we put x is equal to minus 2? If we put minus 2, then we get 2 times of minus 2 cube plus minus 2 square minus plus 13 to 26 plus 6. This comes out to be minus 16 here, and you get plus 4 over here. So it comes out to minus 12 plus. So it is not coming out to be 0. This implies x is equal to minus 2 is not one of the root. So let's try x is equal to plus 2. Let's try x is equal to plus 2 and see whether this satisfies or not. So what happens if we take x is equal to plus 2? So we get 2 into 2 cube plus 2 square minus 13 into 2 plus 6. what do we get here? 8 and 2 16 plus 4 minus 13 into, we get minus 13 into 26 plus 6. This comes out to be 20, and here you get minus 20, which comes out to be 0. This implies x is equal to 2 is one of the root of this cubic polynomial which we have taken here, right? So our job is almost done. Let's see the Horner synthetic division method. So write down the coefficients, all the coefficients of the variables. This 2 plus 1 over here, minus 13 from here, and plus 6 from here, right? So let's do this. So 2 plus 1 minus 13 and 6. Draw two lines like this, and your one of the root was x is equal to 2, right? 2 here. Okay, so now bring this first coefficient directly below here. Now multiply this coefficient with 2 here. You get 2 to the 4. So write 4 here. Add this 2. 1 plus 4 equals 5. Now multiply this 5 with 2 again. What do you get? 10. Right? 10 over here. And add these two numbers. What do you get? Minus 3. Okay. Now multiply minus 3 with 2. So you get minus 3 with 2. So you get minus 6. Minus 6 and write it over here. Add these two numbers. You get 0. So this three numbers, they will form a quadratic equation like this. 2 x square plus 5x minus 3 equal to 0. So your one of the root was x is equal to 2. Now you can find these. Now you can solve this quadratic equation to get the other two roots, and then you will get all the three roots of the cubic polynomial which you originally took. So let's solve this equation. So we can factorize it as like this. So write it as 2x square plus 5x minus 3 plus 5x minus 3 equal to 0. So we see here 3 2s are 6. We can factorize it, right? Or we can use one different approach. What can it be? We can write x is equal to minus b plus minus square root of b square minus 4 into a into c. C is minus 3 actually, right? So we will use minus 3 here. B square minus 4 AC upon 2 times of A. You can use this trick or use this formula, or you can factorize it directly to solve the polynomial, this quadratic equation, to get the other two roots. What if we can factorize it? Let's see. Through factorization, we can solve as 2x square plus 6x minus x minus 3. Is it correct? Yes, minus 3 is here, which is equal to 0. So we can take 2 common here. 2x plus, you get x plus 3, and you can take minus 1 common from here. You get x plus 3 is equal to 0. So you can write it as x plus 3 and 2x minus half. 2x minus 1 is equal to 0. So your two other roots are x is equal to minus 3 and x is equal to half. So your total three roots you got for this cubic polynomial which you took earlier, and your first root was x is equal to 2. So these three roots you get for the cubic polynomial which you took for the polynomial, the cubic polynomial was x cube plus x minus 13 of x plus 6, right? You can put these two roots here, and you can cross check that these two roots correctly satisfy this cubic polynomial. So this was all about Horner's synthetic division method, and by far it is the most easiest and simplest way to solve a cubic polynomial. Thank you.